So recall that an Euler circuit is a circuit which uses every edge exactly once. So we would like to have some understanding of when a given graph possesses an Euler circuit and when it does not. And we would ideally like some kind of useful criterion to do this, something that was easy to check. So let's just try to find an Euler circuit. We have to choose how to leave that vertex. And now we have to choose another edge. And we have some various choices. So notice I've hit this vertex again, but I don't care about, I can go through vertices over and over again. I don't really care. I just want to make sure that I always choose distinct edges. Notice this vertex right here. We came into it via 1, we left via edge 2, and now we're coming into it again via what I've called edge 4. So since we're not done, we have to be able to leave. Unfortunately, we have an edge that's left. So now that vertex is done. We can't visit it again, right? We've used all the edges. This 6. And again, notice a kind of the situation at this vertex right here. We came into that vertex here via 3. We left via 4, and now we're coming into it again via this edge 6. But not everything is done. I haven't used every edge. I haven't returned to my starting point. But in this case, fortunately, I can exit. There's only one way to exit in this case, and that's via edge 7. And then I can go back up here. And again, we have a similar situation, right? That vertex right here, I had come into it via edge 5. I left via 6. And now I'm entering it again via 8. And well, since not everything is done, I need to leave that vertex, and fortunately there's an edge there for me. And now I can go via this edge here, this vertex right here. We came in via edge 7, left via 8, and now we're coming into it again through edge 10. And now, fortunately again, there's a way to leave it. And then finally, we use this edge, and that'll be 12. And now we're back at our starting point, right? Which was this one right here. So here we've constructed an Euler circuit. It has, right, this is the sequence of distinct edges. There are 12 such edges, and we've used every single edge exactly once. We never had to repeat an edge. So now let's look at another example, right? So here is a graph, and again, we would like to try to find an Euler circuit. We don't necessarily know ahead of time whether one exists or not. So we just have to choose an edge. And now we have some choices. So let's go down here. Call this 2. Let's go here. This will be edge 3. Now we have no choice. We leave via edge 4. And now let's say we want to use this diagonal right here. Call that 5. And then let's say we go down here. Call that 6. And now you start to see what our problem would be, right? Now from this vertex here, I have only one choice. I have to go this way through what I call edge 7. But now I arrive back at this vertex right here. But now you kind of see the problem. We came into that vertex through edge 4. We left it via edge 5. And now we're coming back in through edge 7. Now here's the problem though. Once we come back into it, we haven't used every single edge. So we need to leave this vertex, but we've already used all the edges up. What we would need is another edge to leave, but there are no such edges. So this kind of illustrates a kind of an idea. So what was true about the previous example that has failed in this new example? Well, in the previous example, we kept having the situations we would enter a vertex, and then we would leave it. And at some point we might revisit again, but we had another way to leave from it. So no matter how many times we came into a vertex, there was always another edge that we hadn't used yet that would allow us to leave from it. That's precisely what failed in this example. This vertex right here, we came into it, we left, but then there was a time we came back to it. We had to revisit it to use an edge, but we could not then leave from it. So the key idea, what was true in this graph that was not true in the second example, is that for every way of entering, there's an exit. The number of times you enter a vertex is the same as the number of times you exit the vertex. And now we're going to develop that idea into what is called Euler's criterion, which is a result that tells us precisely when a graph has an Euler circuit.